Okay, today we're looking at section 7.2, which deals with multiplying powers with the same base. So hopefully by the end of this section, you can say that I can multiply powers with the same base. So the first thing we need to look at is some wording or some terminology. And so when we're looking at powers, the base number would be like the a in this expression. That is called our base. The red number, the 3 there, that of course is referred to as our exponent. And the entire thing, the a to the third, we refer to as a power. Okay, so with that in mind, when we're looking at things like this, if we talk about the base, we have the base of 3 and the base of 2. And what does 3 to the second mean? Well, that does mean, of course, 3 times the 3. So that would be 3 to the second. And if we look at 3 to the fourth, that really means 3 times 3 times 3 times 3. So really what we have is 3 to the sixth out of that one. If we look at this bottom one, I got 4 to the fifth, which really means 4 times a 4 times a 4 times a 4 times a 4. So that's the first one. 4 to the third means 4 times 4 times a 4. So if we multiplied that, that would really mean, if I wrote it in exponential form, it would be 4 to the 8th power. So the question then becomes, is there an easier way? And hopefully we can see that to get this 6, if we focus on the 2 and the 4, all we have to do to get those is add the 2 together. And if we look at the second one, 4 to the 5th and 4 to the 3rd, if we multiply those two, really what we're doing, we're adding the exponents to get to 4 to the 8th. So what's the rule? The rule would be something like this. If bases are the same, add exponents. Okay, so let's look at the next slide and let's look at some examples now. So if I had 10 to the 7th times 10 to the 2nd, we could simply write that as 10 to the 9th, just simply by taking 7 plus 2, that would give us 10 to the 9th. So if I look at this next one, I've got 6 to the 3rd times 6 to the 1st times 6 to the 3rd. To figure that out, I would simply add those three numbers together, the 3, the 1, the 3, and I would get, or looks like a 3, hard to tell if it's an 8 or not. I believe it's a 3 though, so that would be 6 to the, so 3 plus a 1 plus a 3, that's a 7. So it'd be 6 to the 7th power. Okay, the same thing applies even if their exponents are negatives. So I have 7 to the 8th times 7 to the negative 1 times 7 to the negative 5. So if I just added those all together, 8 plus a negative 1 is 7, plus a negative 5 would be 7 squared. Okay, and on this last one, I've got 4 to the negative 6 plus 4 to the 3rd plus 4 to the 4th. So in the end, I would end up with 4 to the 1st. Okay, so now let's see if you can take a look at some of these. And I'll give you a little time. You can pause the video, see if you can work through these, see if you can get the answers here. Okay, so first of all, on this one, this first one, we should look at it and we should see that we got a negative 3 and a 7. Those two numbers can be multiplied together to give us a negative 21. Okay, after that, we look at our bases of a's. We got a to the negative 1 and an a to the 5th. If we multiply those together, we do end up with a to the 4th. So our entire power expression would be a negative 21 a to the 4th. If I look at this next one, similar, I take a look at the negative 3 and the 12, I multiply those and I get a negative 36. Okay, if I look at j to the 6th and j to the 1st, if I multiply those, this is really j to the 1st, so that would be j to the 7th in the end. Okay, this next one, m times an m to the 4th times an m to the 2nd. This is m to the 1st again, so that would be m to the 7th as well. Okay, now this next one. So if I multiply these two numbers, I'd have a negative 40. If I look at the base of h to the third, the base of h, and I've got that to the negative fourth. If I add those two together, I'd get h to the negative 1. However, we learned that we do not really like to write things with negative exponents, so all I'd have to do there is move that to the bottom. So it'd be a negative 40 over h to the first, or just negative 40 over an h. Okay, so far so good. Let's take a look at a few of these. So try and multiply a few of these out, and then we'll take a look at them. Okay, so the first two I see now are identical to the ones we just did, the same problem. So let's move on to the next one. If I've got the x's, I've got an x to the third, I've got an x, and I've got an x to the negative 2. So x to the third and an x, that'd be x to the fourth, and then the next to the negative 2 would be take us to x squared. So I have an x squared. I've got a y to the negative 1, I've got a y, and I've got a y squared. So negative 1 and a 1, those would cancel out. So really what I'm left with is simply a y squared. So what do we have in the end? We've got an x squared, y squared. Okay, this next one looks pretty complicated, but let's just see how complicated it really is. So I've got a negative 3, I've got a 2, I've got a 7. If you multiply all of those together, I believe we come up with a negative 42. And then if I look at the base of f, I've got an f squared, I've got an f, I've got an f to the third. So an f squared times an f would be an f to the third, times another f to the third would be f to the sixth. Okay, and then the last one I got g to the negative 3, a g to the 1, and a g to the negative 2. So that would be, if I multiply those together, I would get g to the negative 4. So now, we do not like negative exponents, so I would simply move those to the bottom. So in the end, my final result would simply be a negative 42 f to the 6th power over g to the 4th power. That would be my power expression. Okay, next thing we got to talk about is some scientific notation. So hopefully we've seen scientific notation before, but just as a reminder, scientific notation is when we change a large number. It's a way to write a large number or a very small number, very often used in sciences. Okay, so the idea is we want to have one number in front of the decimal. So in this case, if my decimal is sitting here, I'd move my decimal over 4 times. So I would have 2.4. And then that would be 2.4 times 10 to the 4th power. Because 10 to the 4th is really 10,000. So 10,000 times 2.4 does give us 24,000. Okay, on this next one, now I've got to move it to the right. So that would be a 3 times 10 to the negative 3 power. So if I looked at these next two, I start with 7.2, and then I'm thinking I'm moving my decimal 5 places to the right. So once, twice, 3 times, 4 times, 5 times. There's my new decimal point. Each one of these little holes gets filled with zeros. So what is that really? It's really, we're talking about 720,000. Okay, if I look at this next one, I start with a 6.8. But now instead of moving it to the right, I'm moving to the left. So I got 1, 2, 3, 4. There's my new decimal. Fill in my spots. So I really have the decimal 0.00068. Okay, with that in mind, we're going to look at this next slide. So we're going to be using these rules of exponents to multiply here, but then we want to write it in scientific notation. So to do a problem like this, we simply first look at the 2 and the 4, and we simply can say, okay, I can just multiply those, and that would be an 8. And then I look at my base 10, and I've got a 10 to the 6th and 10 to the 9th, and hopefully we can see that that would just be 10 to the 15th. Now, the final question you ask, is it scientific notation? Do I have only one number in front of the decimal? And if my decimal is here, yes, I only have one number in front. So this right here would be my answer in scientific notation. Okay, the next one, very similar. I take a look here. I've got these two numbers, and I believe this is a 10 to the 8th. I'm just going to rewrite that so it's a little easier to see. So first of all, the negative 3 and the 3, all I got to do with those two is multiply them, and that would be a negative 9. And then I have a 10 to the 8th and 10 to the 5th. So if I use my rules and add those exponents, I get 10 to the 3rd power. Okay, and now on the next one, I've got these two. I've got a negative 7 and a negative 8. So together, if you multiply those, you get a 56. If you look at the uh, last part of each expression, you got 10 to the 11th and you got 10 to the negative 4. If you multiply those two, you would get 10 to the 7th. Now, is that scientific notation? And the answer here would be no, because I have more than one number in front of the decimal. So here's how what I have to do. I have to change it. So my decimal is here, so I move it one place. So that becomes 5.6. Now, what would happen to my 10 to the 7th to justify moving that? Well, if I move this one, this 5.6, if I moved it from 56 to 5.6, that number got smaller. So in order for these two expressions to be the same, this number would have to get one bigger. So it'd be 5.6 times 10 to the 8th would be my final answer. Okay, let's take a look at another one like that. Okay, so I've got a 6 and a negative 6. If I multiply those, I get a negative 36. Okay, and now I've got 10 to the negative 7 and a 10 to the negative 4. That would be a 10 to the negative 11. So now once again, I've got to move my decimal. If I move my decimal one place, that'd be a negative 3.6. If this front number gets smaller, this back number is going to have to get bigger. So if I get bigger, I'd have to add 1 onto that. So that would become a negative 10. Okay, so hopefully that all makes sense to you. If you have questions, make sure you're bringing them up in class. And that is a wrap.